Hi everyone. In this video we're going to go over how to calculate vector components, which basically means if you're looking at a diagram like this, how can you find the horizontal and the vertical components that would make up a vector that points in this direction of this length. Question 1 says calculate the horizontal component of the velocity vector shown and label it on the diagram. So for both the horizontal and vertical components, we're going to be using two formulas on the last page of the physics reference table. So AY equals A sine theta and AX equals A cosine theta. A in this case stands for any vector quantity. So that could be a velocity, it could be a displacement, it could be a force, basically anything that's labeled on an arrow. AY and AX are supposed to represent the vertical and the horizontal components of that vector. Sine and cosine are just buttons on your calculator, and theta represents angle, and that's shown right here. So since I'm supposed to look for the horizontal vector, or the horizontal component of the vector, I'm going to label it like this, and I know I'm going to be using AX equals A cosine theta as my formula, so I'm going to list out my variables. AX is what I'm looking for. A is 8 meters per second, and it's always going to be just that number that's labeled on the arrow. Theta is always going to be the angle, so 35 degrees. I'm writing down my formula, I'm plugging in my numbers, and you need to type this into your calculator exactly as you see it here. So 8 cosine 35. And my answer is 6.55. Now if you got something else, you might be in the wrong mode. So there's a mode on every calculator for radians and a different one for degrees. You need to be in degrees mode. If you're in radians mode, you're going to get the wrong answer. So 6.55 is the correct answer. And the unit is meters per second because that's the same unit that we started with. So the unit doesn't change. So I can fill in my label Vx equals 6.55 meters per second. For question 2, we're going to calculate the vertical component of the velocity vector shown and label it on the diagram. We're doing basically the same thing, just using a different formula. We're going to be using the formula for Vy, or the vertical component. So instead of Ax, I'm solving for Ay. But the vector is still the same. It's still 8 meters per second, so I don't change this. And theta is still the same. The angle is still 35 degrees, so I don't change this either. I just use a new formula. Instead of Ax equals A cosine theta, I'm using Ay equals A sine theta. And I have to plug in my numbers like this. 8 sine 35. This is exactly what it should look like on your calculator, just typing it in like this. And that gives me 4.588, or I could round that to 4.59. And that's going to be my answer for the vertical component. For question 3 and 4, you're doing basically the same thing that we did in questions 1 and 2. The only thing that's different is it's a force and not a velocity. But that's not actually going to change anything about the way you do it. So for question 3, you're looking for the horizontal component, so you'll still be using Ax equals A cosine theta. The only thing is that when you label your horizontal vector, you're going to label Fx for the horizontal component of the force. And then for question 4, we're looking for the vertical component. So we're going to use Ay equals A sine theta. And then again, when you're labeling that, you'll label that Fy instead of labeling it Vy, because now it's a force and not a velocity.